Alright guys, welcome to today's class. Today we're going to continue where we left off and look at area and perimeter. Alright, so let's get started. At 4.21, 2.1, we want to find area of each of the figures shown. Alright, this is pretty easy. Remember, a chair is of a triangle, which is obviously base times height, divided by 2. Or 14 in this case, since 4 times 7 divided by 2 is just 28 divided by 2, or 14. Alright, we're going to apply the same logic here. Alright. Hopefully you guys have heard about the Pythagorean theorem. But what Pythagorean theorem states is that a squared plus b squared is equal to c squared, where in a triangle there's a, b, c. And that's how you solve for the area. Right? This case, we don't have a. In this case, I say that's a and that's b and that's c. We can apply it, and you get a is equal to 6. And then you can find the area, which is 24, with base times height divided by 2. If you didn't know, though, you can see that clearly that the 4.8 in this question, the 4.8 is the height, or it's a perpendicular drop from E to DF. And DF is the base. So multiply it, and you also get 24. All right? Finally, for C, for a rectangle, it's just base times height. So for this question, it's just 112. All right? Let's get started with 4.2.2. What is the area of the square ABCD if the perimeter of the square is 36? I'll ask you to have a try this question and tell me answer the chat. Let's get started with this question now. So clearly that the perimeter is 36, and in every single square that all the sides are the same. So say if the sides were x, then 4x was 36, or x is 9. Using base times height, you get x times x, or x squared. That's 81. Right? Now let's move on to 4.2.3. In the diagram at right, KO is 6, LM is 7, and KM is 12. Find KOM, and then find LN. Right? I'll just have to try this question and tell me in the chat. So you should first find KOM, because then after that, after finding the area, you can find the height. Right? Which is LN. Right? Anyways, I'll just have to try this question and tell me in the chat. All right, let's get started with this question now. So how do you approach this question? Oops. Well, KOM, this bracket denotes area of a triangle, all right? Just so you know for future uses, all right? So this KO is actually the height of this triangle, all right? We want a height of a triangle is just always the perpendicular to the base. What we're looking at, we denote a base. The height comes from the very uh the point that's not used. For example, if we denote our base as OM, the point that's not used is K, and the height is perpendicular to OM coming from K, and that's our height, KO. And then we also know KO 6 and LM is 7, so the area is just 7 times 6 divided by 2 or 21. LN, well, since we know KM, it's just going to be 21 times 2 divided by 12, or 21 divided by 6, or 7 halves. And that's our answer. Why I multiply by 2? Because we always divide by 2 when we do multiply. I mean, when we find an area of a triangle, we always divide by 2. So in this case, we have to multiply by 2 to account for that, right? So let's move on to 4.2.4. 1 gallon of paint covers 80 square feet of wall. How many gallons of paint do I have to buy if I am going to buy 2 rectangular walls that are each 24 feet long and 8 feet high? Let's get to try this question and tell me through chat. All right, let's get started with this question now. So basically, how do we approach this? Well, notice that 1 gallon paint covers 80 square feet of wall. And we have two of these that are each 24 by 8. We first find the area of one of those, which is going to be 64 times 3 or 182. All right? Afterwards, we notice how we have two of these. So we multiply, and we get 384. And notice that we have 80 for 1 gallon. So we basically divide and find the remainder, which is 64, which covers 4. And 64 divided by 80 is basically 80 divided by 10, or 4/5, or 4 4/5 of gallons. All right, now let's move on to 4.2.5. A square poster is replaced by a rectangular poster that is 2 inches wider and 2 inches short. What is the difference in the number of square inches between the area of the large poster and the small poster? All right, so first off, we notice that our original poster is XY in area, meant X squared in area. Afterwards, we have X plus 2 times X minus 2. One of the sides is shorter by 2 inches and one of the sides is longer by 2 inches. Expanding gives us x squared minus 4 and x squared minus of that. Or 4 as our answer. That's the difference. So there's a key formula. This is just x plus k times x minus k is equal to x squared minus k squared. This is a very important formula to memorize. You're going to use it a lot later on in your mathematical career. Anyways, let's move on to 4.2.6. The perimeter of the square garden is 64 meters. The path surrounding the garden has uniform width and has an area of 228 square meters. How many meters of fencing is needed to surround the outer edge of the path? I'll let you have a try this question and tell me through chat. All right, let's get started with this question now. So basically, how will we approach this? Well, the square garden is right over here. I believe so. And that's the perimeter of this is the square garden. All right. So since it's a square garden, then the side length of that square is going to be 16. All right. Therefore, from here, we know that this area is going to be 228, and we have 16 squared is 256. Add this all up, you get 484. And that's the total area of that square. And we want the total meters of fencing that need to surround the outer edge of the path, or this square. Notice that this is another square. And we're just looking for the perimeter now. Notice that the square root of 484 is just 22, because 484 is equal to 4 times 121 times 4, which is just 11 times 2, or 22. So each of the sides is 22. Add this all up, it gives you 88 as your final answer. Alright, so basically it's just algebraic manipulation. Or basically just solving. Alright? That's the 1, 2, 4, 1, 3. Same base and same altitude. Alright. Let's start with 4.10. Problem 4.10. If given that BC is 40, CD is equal to 20 in the figure, what are ABC and ACD? And what's ABC divided by ACD and ABC divided by ABD? I also got to try this question in terms through chat. All right, let's start with this question. What is ABC to ACD and ABC to ABD? So we're comparing ABC to ACD, and ABC to ABD. Notice that the height is the same. This chapter is about same height, same base, and same altitude, or same height and same base. The altitude or the height, they both have the same exact height because their base is both on the line BD. I mean the line segment BD, and there's just sections. All right, so the heights are the same, and we're comparing the areas right now. So all that matters is comparing the bases, and ABC to ACD is just 40 to 20. 20 or 2 to 1. Now ABC to ABD, well, since ABC is 2 times the area of ABCD, then the total area is just 3 times ACD, or 3 halves of ABC. Since this is 1, this is 2, means the entire area is just 3, and 3 divided by 2 is just 3 halves. Now let's try 4.12 now. AC and BD meet at X is shown below. ABX is 24, BCX is 15, and CDX is 10. Find ADX. Same exact way, find similar heights, the same heights, and then use it with area ratios, just like as we did in the 4.10. We found area ratios, and then we use that to help find this base ratios. I'll see you later. Try this question and tell us through chat. Let's get started with this question. So in order to do 4.12, first off, notice that we want to find ADX. So we had to compare the bases. Notice that in ABC, ABX's height is same as BXC. So 24 to 15 is just the ratio to the bases. Or this is just 8 to 5. Because that's 8 to 5. And we know that this height is also the same. This is the height too, and they're the same. Notice that x ADX, this is the area, ADX divided by 10 is equal to 825. Solving is 16. And that's our answer. We could have done it the other way. We can use BDC and found that this is 3, this is 2, and done the same exact calculations, but it works either way. Alright? Now let's move on to 4.3.1. In the diagram below, PT is equal to 6, TR is equal to 3, and QB is equal to 4. Find PQR, PTQ, and QTR. I'll let you know for trying this question in 10 minutes to chat. All right, let's get started with this question now. So basically, how would we approach this? Well, note that PVQ, PQR, PTQ, they have all, and QTR all have the same heights. So all that matters is the base. Notice that QV is 4, and we know that PT is 6. QV is 4. And TR is 3. And we want to find PQR. PQR in this case is just 4 times 9, since the total length is just 9. Divide by 2, or 18. I'm actually do write it under. 18. PTQ, same exact method. Notice that the height is 4 and the base is 6. This would be 12. 24 divided by 2 is 12. And similarly for QTR, this is 12 divided by 2, or 6. Now we want the ratios. We want TR to PT. But notice that this is just height base ratios, or this is just 2 to 1. Notice that QTR to PTQ is just equal to TR to PT because of this. This is the triangle. I'm gonna highlight it. This is PTQ, and this is QTR. So that is just gonna be 1/2. Same exact ratio, basically. All right. So basically, that's how basically how ratios work. Base ratios work, right? Now let's move on and let's actually try 4.3.4. By what factor is the area of a triangle multiplied if the length of its base is double and the height is triple? I'll also have a try this question and tell us to chat. Alright, let's get started with this question now. So here comes the tricky part. By what factor does it increase, multiplied by if it's doubled and then it's tripled? If the length is this side, length is doubled, and the height is tripled. Well, the original formula is base times height divided by 2. Therefore, the base will be 2 base times 3 height divided by 2 is just base times 3 height. Or it's just 6 times base times height divided by 2. Because remember the divide by 2. It's very important. Or should it says 3. So it's actually 6. Alright? So that's it for today's class. Hope you guys have a wonderful weekend. And I'll see you next week. Bye.